In this video, we're going to look at Coulomb's law, and it's the force that point charges exert on each other. And how do we calculate that? Well, if you have a positive charge and a negative charge, we know that the forces attract each other. Doesn't matter what the size of the charge is, the forces will be exactly the same to each other. If you have a positive and a positive, they'll repel each other, and we also know if you have a negative and negative, they'll repel each other. Coulomb's law is the following equation. It's F, the force, between the two charges, equals K, the electrostatic constant, times Q1 times Q2, and those absolute value signs make it so that the force is positive, divided by R squared, and R is the distance between the two charges. So our force is called the electrostatic force in newtons. The K value is electrostatic constant in Newton meter squared per Coulomb squared. Q is the charge in coulombs. R is the distance between the charge, and that's measured in meters. So you can see here, these yellow dots are negative charges. And if I take it closer and closer and closer, you can see the force gets larger and larger between the two. It gets very large as it gets very close. And if I bring it closer, this negative charge closer to the other negative charges here, you can see the force gets very large again. And I can bring these, I can find what the force is at any point, how large the force would be. Now, an interesting idea here is that in the Bohr model of the hydrogen atom, the electron, negative E, is in orbit about the nuclear proton, positive E, at a radius of 5.29 times 10 to the negative 11th meters. Determine the speed of the electron, assuming the orbit to be circular. So I want you to pause the video and see if you can think of how you would solve this problem. The way you would do it is think of this as being a centripetal force, mass times acceleration, which is equal to mv squared over r. Now we know the force is also electrostatic force, which you can calculate by F equals K Q1 Q2 over r squared. So you plug in your values, you plug in your electrostatic constant of 8.99 times 10 to the 9th, you plug in your charge of 1.6 times 10 to the negative 19th coulombs, and your other charge of 1.6 times 10 to the negative 19th coulombs, because that's the charge of a proton and an electron. Here's your distance between them, 5.29 times 10 to the negative 11th meters, and that's squared. You come up with a force value of 8.22 times 10 to the negative 8th newtons. Set that equal to your mv squared over r, and you end up with an answer of 2.18 times 10 to the 6 meters per second.